In this video, we're looking at the GepRC Smart 35 airframe. We're going to look at the components we're going to need and how to fit them out in the airframe to produce something like this. In particular, we're going to be looking at the dual stack mount that this airframe has and how we can use that so we have a flight controller and ESC up the front and all of our VTX components down the back. Let's get started. Hey everyone, Cube here. Welcome back to the workshop. Today we're going to look at fitting out all of the components in the GepRC Smart 35 airframe, and I'm also going to take you through a little bit of the process I use in designing the layout. And one of the first things I start with is what I call a stack designer. This is just a piece of wood, and I can actually design my stack and lay the stack up on here and see if all the components will fit. So the stack I'm using for this build, it's a Diatone Mumba F405 Mini. You can see the ESC there and the flight controller just above it. And then above that, I've got the native Vista unit. So I can use this stack just to see how I can fit the components and get them to fit the best. And sometimes I'll even flip a board over if it means saving a bit of space. So once I do that, I can actually just measure it and see if it'll actually fit in the frame. So if we have a look at it with the frame here, okay, you can see it's a bit hard to see there, but actually it will fit in the frame, but it's an extremely tight fit and it doesn't actually give me as much clearance as I'd like to have. You can see this is the flight control is actually butted up against the baseboard there, so I need to add a couple of extra spaces there to lift that up, and basically it just means it's not going to fit in this configuration. But that's actually okay, because this airframe will allow us to do dual stacks. We can have one stack at the front here for mounting the ESC and flight controller, and then another stack at the back here for the VTX. So at this stage, I like to start mounting all of the components on the frame itself, and without any wiring, just put the components on and see how they're going to fit out on the frame. Let's start with that. Starting with the standoffs here, we've got 22mm M2 bolts. And you'll notice on the rear stack I'm using single nuts, and on the front stack I'm using dual nuts, double nuts. So that's just to give us a little bit more clearance. You can see there's a lot of components hanging down underneath the ESC there. So the double nuts just give us a little bit more clearance between that and the frame. Okay, so we'll just start seating all the components on. So first one that goes on is the ESC, the 4-in-1 ESC. And then we'll put the flight controller on, and we'll have a look at something with the flight controller here. I'll just get a bit of a close-up. Okay, so you can see the issue here. The flight controller up the front there is very, very close, actually touching the standoffs. So we really don't want that, and that can actually cause vibration to go into the flight controller. So we're going to have a look at a bit of a solution for that. Okay, and the only solution here is to actually use a smaller flight controller. So just a little bit of a note, if you're building this for yourself, if you're doing this build for yourself, the flight controller is 29, let's say 29mm. Okay, so you have to remember that 29mm is not a good, is not good for this GepRC Smart 35 frame. Okay, so here I've got this one is a Foxeer Mini. So this is the F22 V2, and if we look at the size of this, it's only 26mm. Okay, so that's going to fit on a lot better. Okay, the only problem we have here is that we've got, whereas on the standard one we've got the M2 mounting holes, this one has actually got M3 mounting holes. So we need a solution for that, so we can fit it onto our board. And of course we're going to have to do custom wiring. We're going to wire up a custom harness and solder directly onto here and directly onto the flight controller board. Or actually I might use the plug-in and solder onto the flight controller board. Okay, so let's have a look at what we can do to change these M3 holes into M2 size. What we use is small little bits of silicon. So this is just silicon tube, and I've just cut them to size. So they slide very neatly over the M2 bolts. There we go. That's how they go on there. I'll just put all 4 of those on. And with those pieces of silicon on, we can now just slide the flight controller down over the top of those. Okay, and it's a nice firm fit, and it won't move at all there. Okay, so you're not going to worry about doing any wiring at the moment. We're just stacking components on and making sure everything fits. So I might just give you a bit of a slideshow and show you the process of how we stack all the components and how they're spaced. Okay, so here we go. We start with the basic frame. We've got our 20 by 20 mounting pattern on the rear and the front, and 2 nuts on the front bolts. Okay, so the first thing we're going to do is put on our ESC. This is our 4-in-1 ESC, and it fits quite well there without touching the standoffs. So above that we've got 2 1mm spacers here, so we've got 2mm of spacers. These are the silicon piece of silicon tube, and that just takes up the room inside the M3 dampeners for the flight controller. Then the flight controller goes on top there, so it gives us adequate space in between. On top of them we've got another 2mm, and on my build I'm actually going to be putting this top plate here and mounting my TVS diode and capacitor up the top here. So of course the wires for this will run down here, over the back and straight down onto the main power connectors on the 4-in-1 board. Okay, so that does it for the front stack. And on the rear stack we're going to have 4mm standoffs on the bottom. I'm just using rubber ones at the moment just to get the spacing. So we're going to have a at least 4mm gap here, so that the power wires can actually go down underneath here and up there and still get adequate airflow in between. Okay, this is the base board of the naked Vista unit, and then of course we need 4mm spacers for the Vista unit. And you can see here's the MIPI connector here. So the lead, I'm using an 8cm lead for the MIPI cable, and it's actually going to go straight through this gap here. There's plenty of gap here, and it's going to go straight through there and to the camera. Okay, then the top board goes on. We've got some washers, 0.5mm washers, and some more standoffs. These are 2.8mm standoffs. And then on top of that I'm just putting another mounting board, and I'm going to have my receiver mounted up the top here. Okay, and all of this still gives us from this area to this area here, gives us a good 5mm for a battery strap to come in there. Okay, and that's basically the setup. So at this point we've got both of our stacks laid out correctly. We've got our spacing correct as well. We'll just have a look at the nuts we're using. And these are M2 self-locking nuts that we've got on the top here, so they tighten themselves. So it means we just don't need to use Loctite on the top there. The next part of course is to take it apart and do our wiring. If you've actually designed your stack like this, what you might like to do is actually just take a photograph of it at each stage as you take each of the boards off, so you know how to put it back together again. So we'll take this all apart and get started with the wiring. And here we are with the main part of the wiring done. Before mounting on the frame I'd like to do a bit of pre-wiring. These are the battery leads here. These will go to the FETTech spike absorber. If we have a look up here, you can see I've actually hardwired the harness, the wiring harness to the flight controller. While we're on this side, I've actually soldered the receiver there. And back on the other side, these leads here are for the buzzer, and these 2 leads here are the TX and RX for the Calyx Vista unit. So with that amount of basic wiring done, we now mount it on the frame and start wiring up. Okay, so here we have it with all of the boards mounted and the wiring complete. So we'll have a look at that under the camera. So here it is with all the wiring done. And the only thing we haven't done yet is actually wired up the motors onto the ESC. I'm going to be using this frame as a test bed. These are actually 1603 motors. They're just the first of the batch of motors I'm going to be testing on this frame. We'll just have a look at the components and the 2 stacks there. So once again we've got the flight controller and the ESC up the front with the FETTech spike absorber on top. Down the back here we've got the naked Vista unit and of course the Express LRS receiver up there. Okay, that's what it looks like. So just as a comparison, we'll have a look at my daily fly here. This is one that's got an all-in-one board down the bottom with the naked Vista mounted directly on top. So that's one option for mounting, and the build we've done here is using the dual stack. Now I'll just put the top plate on, and we'll just have a look at the clearances that we have. Okay, so just turning on the side here, you see we've got plenty of clearance for the battery strap to go through there. So there you go, that's my preferred setup for the GepRC Smart 35 3.5 inch. Watch out for some flight videos. I'm going to do some flight videos and motor testing videos as well. At the moment, I'm using the iFlight Zing 1504 3100 kilovolt motor on my daily flyer here, and I'll be doing some testing to see if there's some other motor options for 3.5 inch. Until then, happy flying.